Welcome to our deep dive into Pythagoras. You've given us like a really fascinating mix of sources. I
Mhm.
see excerpts from a book in Spanish, some historical accounts, even some modern analyses.
Yeah.
It seems like you're interested in going deeper than the Pythagorean theorem, right? You want to get the man, his followers, and how those ideas, still have an impact today.
Absolutely. I mean, it's incredible how Pythagoras' life is wrapped up in, like, myth and legend,
Yeah,
born around 570 BC.
right.
But separating fact from fiction,
Yeah.
that's a real challenge with him.
Right. Well, the sources mention a golden thigh legend. That
Right.
sounds more like a superhero or something than a historical figure.
Yeah, some scholars, they connect it to, like, shamanic practices, but these fantastical elements, they were pretty common in ancient biographies.
Yeah.
It's almost like the more incredible the stories, the more influence the person had.
Oh,
And
interesting.
Pythagoras. Yeah, he was definitely influential, especially in the world of ancient Greek politics.
So he wasn't just some solitary math guy.
Yep. Not at all. He founded a school and had followers, the Pythagorean Brotherhood, and they had serious political pull in ancient Greece. They were kind of like an exclusive club, very secretive, with their own set of rules, their own rituals.
So like a secret society with math at the center.
Exactly.
That's cool.
And to really get this brotherhood, we've got to understand how it was set up. There were the schismatics, more like initiates. They'd memorize sayings and teachings, but not necessarily the deeper meaning. And then you had the mathematicians. They were the inner circle. They were the ones exploring the reasoning, the logic behind everything.
So kind of like having, a general audience and then like a VIP section for the math enthusiasts.
That's a great analogy. And these teachings, they were called akismata, offered all sorts of guidance, practical, philosophical. Like one of them says, do not stir the fire with a sword.
Oh, okay. So like don't add fuel to the fire, think before you act, that kind of thing.
Precisely. But here's where things get a little interesting. With all that emphasis on logic, on numbers, the Pythagoreans also believed in, like, the immortality of the soul. They even participated in conventional Greek religious stuff, at animal sacrifices and all that.
So, like, bridging the gap between rational thought and spirituality, the world of numbers, but also the world of faith.
Yeah.
Interesting. But what about that core belief of theirs, the whole idea that numbers were the foundation of reality itself?
Ah, yes. That's the heart of Pythagorean philosophy. They thought numbers were more than just abstract symbols. They believed they were the actual building blocks of the universe. And they took it a step further. They visualized those numbers as geometric shapes.
So they weren't just thinking numbers, they were picturing them.
Exactly, like 1, 4, 9, 16. They saw square numbers as literal squares, made of points. Same with triangular numbers, 1, 3, 6, 10. Each one was a triangular arrangement of points, and by linking numbers and shapes, they started unlocking deeper patterns, proportions.
Wow, that's a pretty elegant way to approach math. It's like they were like figuring out the universe's code, but visually.
Yeah. And this way of seeing things, it affected everything for them, from music theory to astronomy. You know that famous story about Pythagoras hearing musical intervals from blacksmiths hammering metal?
Yeah.
Well, that sparked their experiments with string lengths, and that led to the discovery of the harmonious ratios of the octave, the fifth, and the fourth.
Wait, break that down for me. How do blacksmiths lead to musical ratios?
So they realized that when you divide a string in half, you get that 2-to-1 ratio. That creates the octave. Divided by a third, you get a 3-to-2 ratio. That makes a fifth. And divided by a fourth, you get the fourth with a 4-to-3 ratio. Those simple mathematical relationships, they make the most pleasing, harmonious sounds.
So they found math is literally built into music.
Exactly. And this discovery, well, it led to their biggest idea,
Mm.
the harmony of the spheres. They believe that the entire universe, it's this huge harmonious structure with the planets moving in, musically pleasing ratios.
So they were composing a symphony of the cosmos.
You could say that.
But didn't they run into a bit of a problem with this whole numbers govern the universe idea?
Yeah, they did. A pretty big problem, actually.
Yeah.
And that's where we'll pick up after a short break.
So we were talking about this harmony of the spheres, right? This idea that the universe is like a perfectly tuned instrument.
Yeah. And as beautiful as that idea is, they kind of hit a snag.
Hmm.
They came across this concept that really shook their whole numerical worldview. Irrational numbers.
Irrational number. Oh man, I kind of remember those from like way back in math class. I think it was something about like numbers that go on forever.
You're on the right track. They're numbers you can't express as a simple fraction. They're decimal representations. They just keep going. No repeating pattern or anything. And the most famous example, the square root of 2.
Okay, but how did the square root of 2 mess up their whole system? It's just one number.
Well, think about it. Imagine a square, right? Sides of length 1.
Okay.
Now, their own theorem, the Pythagorean theorem, says the diagonal of that square should be the square root of 2, but they couldn't figure out how to represent that length as a ratio of 2 whole numbers. It was like this wrench thrown into their perfectly harmonious whole number system.
Wow, it's kind of poetic, you know? Their own theorem led them to a discovery that challenged their most basic beliefs.
It really shows you the limits of even the most beautiful, elegant systems.
Yeah.
And then there's the story of Hippasus, the Pythagorean who supposedly told the world about this whole thing, this secret. Legend has it they drowned him for it.
Whoa, talk about taking your math seriously, but their influence didn't just like disappear, did it? Even with this whole irrational number thing.
No, not at all. Pythagorean ideas, they kept echoing through history, inspiring philosophers, mathematicians, artists, everyone. Like, think of Plato. He imagined this realm of perfect forms, eternal, and they transcended the physical world, which was imperfect. He was totally into that Pythagorean idea of a mathematically ordered cosmos.
So even though irrational numbers kind of messed things up, the torch was still passed. Like, that quest for math kept going.
Exactly. Even Aristotle, who wasn't always on board with Pythagorean ideas, he knew how important their contributions to math and philosophy were, and that quest to find order, mathematical order, in the universe. It kept going for centuries, influencing thinkers like Kepler, who tried to describe planets moving in these musical harmonies, and Newton, whose laws showed a universe running on these precise mathematical relationships.
It's wild how these ancient Greek thinkers basically laid the foundation for so much of what we know about the world today.
It just shows how powerful ideas can be. They go beyond time and place. But the Pythagorean legacy, it's bigger than just specific discoveries or theories. It's a whole way of thinking, a spirit of inquiry, a belief that the universe makes sense, that we can understand it using reason, observation, logic.
It's like they gave us this set of tools, right? Not just for math, but for like thinking in general, to go explore the world.
Exactly. And those tools, they're just as important today as they were way back then. We're still looking for patterns, trying to make sense of everything, still driven by that same Pythagorean curiosity.
And that's what makes this whole deep dive so cool. It's not just ancient history. It's about something, really human, this desire to understand who we are, where we fit in with everything.
And maybe even, compose our own music within that grand symphony of the cosmos. Yeah, now you're talking. Let's take a second to kind of absorb all this, and then we can get into some specifics from the sources, see how the Pythagoreans actually put these ideas to work. Okay, so we've covered the Pythagoreans' big ideas, but I'm curious, how did this stuff actually play out? What kind of concrete examples do we have from the sources?
Well, one thing that stands out is how interested they were in what they called figurate numbers. Those arrangements of points that make geometric shapes. We talked about square numbers and triangular numbers before.
Right. They were literally seeing numbers as shapes.
Exactly. And that visual approach, it led to some really interesting discoveries. They figured out that when you add up consecutive triangular numbers, the answer is always a square number.
So 1 plus 3 equals 4, 3 plus 6 equals 9, and so on. That's neat. It's like a math puzzle, where everything fits together perfectly. It is. And it shows how they could connect arithmetic and geometry so beautifully. They saw these kinds of patterns everywhere, which just made them more convinced that numbers held the key to, the whole universe.
Speaking of patterns and relationships, what about those sayings, the axiomata? Did those tie into their number-focused worldview too?
Some definitely did. Others were more about ethics, living a good life, that kind of thing. But there's one that really sums up their whole philosophy. What is the most beautiful thing? Harmony.
Wow. So much meaning packed into such a short sentence.
It shows how much they believe that beauty, order, proportion, it was all connected. And that math, that was the language to express all of it. It wasn't just about, doing calculations. It was about finding the elegant structure underlying reality.
So even though they weren't right about the universe being totally numerical, their ideas about patterns and relationships, that's still relevant today, right?
Absolutely. I'd say their legacy is more about a way of thinking than any specific discovery. That constant curiosity, challenging assumptions, going after knowledge even when it makes you uncomfortable, like with those irrational numbers. Those are valuable qualities no matter what you're studying.
It's like they gave us this blueprint for like intellectual exploration, a toolbox to tackle any problem with curiosity and a desire to find the underlying order.
Exactly. And that's why I think the Pythagoreans still resonate with us. Scientists, artists, just curious people in general. We're all drawn to the beauty of patterns, the elegance of logic, the excitement of finding something new.
It's like that saying, the more you know, the more you realize you don't know. That's what keeps us searching, keeps us questioning, keeps us, diving deeper into the universe's mysteries.
Well said. And if this deep dive has sparked your own, Pythagorean curiosity, I really encourage you to explore more. Go read about the history of mathematics, check out Plato's writings on the harmony of the spheres, listen to some ancient Greek music. You might be surprised what you find, how these old ideas still speak to us today.
It's been like a treasure hunt. Through history, we found all these hidden gems of wisdom and insight. Thanks for joining us on this deep dive into Pythagoras and the harmony of the universe. Until next time, stay curious and never stop exploring the beauty of patterns, the power of ideas.